Alright, so this simulation actually caching cost me a crash, and I got blue screen too for some reason. So I lost everything. So I'm gonna actually say, if you wanted to try this, you have to wait for a while. I'm just gonna abandon this, but this is one of the working ways. It just takes a lot of time. So I'm gonna delete those guys. I'm gonna actually show you a different way that is could be cheaper than the fluid source. So I'm gonna drag out from attribute wrangle. I'm gonna create a VDB, right? VDB and VDB from particles. Right? If you take a look, now we have nothing. Now I have a warning here which says that you probably need the minimum radius and voxel, right? The smaller the radius is, the more voxel you will be able to create. So you can lower that down to maybe 0.5. And we're not seeing anything, maybe 0.1. And now we're seeing something. It's generating based on that. Of course, there's another setting that we can do. Let me change that back to 0.2 or so, which is the voxel size, which determines the resolution. So 0.05 would be better. Also, now we're getting much higher resolution. Okay. And now let me actually go ahead and turn off the grid and also the original geometry so that we can only see this, and I don't need a sand distance field, right? So check that out. I actually need a fog, so check the fog out. Okay, now I have the fog. As you can see, it goes through the animation pretty quickly. This is much faster than fluid source because VDB knows when there's nothing and it will ignore that. But fluid source will fill in stuff as zeros even there is no stuff. So let's see, I kinda wanted to see a little bit more. Let me actually turn on again the template on my geometry so I can see how exactly things are looking like. So I'm gonna need maybe a little bit more point size, so maybe change that to 0.1 or 0.08. Yeah. Kind of like needs a little bit more density maybe. Let's try 20. Not really making any difference. Making the density attribute should be working. 200. No. Well, just gonna have to change that back to 1. P scale is the same. I'm not sure why, but maybe that's because of the age. Anyway, so I'm gonna go for the what I have now, and I can enhance the density later on. Those are just emitters, so not quite important. Point attribute, I mean they are important, but not like I have to be really shape-wise be really close to what I want eventually. Just have to be something I can start with. Still getting a lot of stuff. Hopefully they're not too much. Let's see, maybe I can just lower down the points radius scale here too. Also 2.8 just to make it them just a little bit more tight. Okay. Alright, so I'm happy with this now. And let's create also a attribute for velocity. So click that plus button, and underneath attribute I'm gonna go for velocity as attribute. That's gonna give me the velocity attribute here, okay, which inherit the original velocity. Now I'm gonna settle down with these. I can maybe a little bit. I use the VOP attribute, volume VOP actually, to actually vary the density here. So here underneath the density, I'm going to use the position to create a noise. I'm going to use a anti-aliasing flow noise. Okay, and then the noise will be added to our original density. So we're using 3D noise. So delete that and reconnect. So density here, add a few more density, right, or a noise, and then we add that. Okay. So that's gonna give me something a little bit more interesting. Okay. Okay, we can also use multiply if you think that's bulging out too much. I think they are. So let me try and multiply, because that's what's happening in the change that to 1D noise. Okay, not seeing much. I guess I'm multiplying it too little because the number could be really weak. So I'm gonna do a remap or clamp that to 0 to 1, and then I can also multiply that. Actually, let's clamp that to 0.5 to 1, so we're getting at least 0.5, and then we're also gonna maybe multiply that by something. We can just multiply something here. So I'm gonna hold down middle mouse button here and promote this to a parameter, and here I'm gonna call it density scale. Okay, and default value could be 1 for now. And also I can maybe also promote the frequency, amplitude, roughness, so those kind of things on the outside of this volume bulb. So I can say, oops, here I also need to change the label to density scale. For this parameter we created. Now let's go outside by pressing the U button, and here I'm going to change the density scale to maybe 2, so we're having more density. And also maybe I can tell it to have a bigger frequency. I'm gonna change that to 10. So we're having smaller detail. And amplitude can be a little bit weaker. Roughness can be, if it's, oops, I'm going negative. So let's see, a little bit weaker of the amplitude, so it's not varying too much. And also maybe just a little bit more roughness, so that it's varying more inside, but not really strong. I can play with those values like 3, just to have a little bit more. Alright, cool. So we never know if this works unless we try them. I'm gonna turn off the template here now, and I'm gonna say this is cool. I'm gonna create a null and call it my smoke source. Okay, so that's the emitter. And all the way back after unpack, I'm gonna also create a VDB, but this time I'm gonna create a VDB from polygons. Now this is gonna be the VDB representation of our geometry. I'm gonna change that again, velocity size to something smaller, like 0.02, to get a decent detail. And it's gonna be, again, this time distance VDB, not the fog anymore, because this is actually used for collision, and this is what's needed. A sign distance field is what's needed for us to do that collision. And here from this down, we're gonna go ahead and create yet another null, right? Oh, before I do that, here I also need a velocity, because velocity does matter. When things are flying, let's change that to point.v. When things are flying and you hit them, the force you get is actually different compared to the things that are not flying or not moving, right? So you kind of need that velocity here too. I'm gonna call this one smoke collision. Okay, so we have the source and the collision. Collision have surface and velocity, while the source have density and velocity. So we're going to use those two things as our emission sources to create our simulation. Alright, so that's it for this tutorial. As you can see, this is actually a little bit more faster. I can even drag through. As you can see, it's almost real time. But just in case, we probably need to, you know, cache them just to make things a little bit more faster. So I'm going to say file cache for this guy. And this is gonna be the smoke source cache. And here no heap name, right? Just the operator string should be good. I'm gonna hold it down Alt and drag this to duplicate this guy and put it here. This is gonna be the smoke collision cache. I don't even have to change anything inside because it's using the operator string, so it's gonna be different. Alright, now let me go ahead and do the save to disk to make it cache. As you can see, it's caching pretty fast, much more faster than the things we have with fluid source. Again, because it knows when there is empty area, it will not actually record anything, just to enhance the performance. Let me do the same thing here. This one could be a little slower, but still it's much faster than what fluid source can give us. Alright, that's gonna be it for this tutorial, and in the next one, when I finish this, I'm gonna go ahead and show you how to actually use these informations we gathered to actually emit smoke using pyro. Okay, see you next time.